Specifically with exponential growth, with a lot of real world examples, we're either increasing by a certain percentage or decreasing by a certain percentage. We're going to talk about how to work with exponential equations and percentages. So we're going to back up just a little bit and talk about what is a percent. So if we look at the word percent, per means for every. Cent is a prefix for 100, right? There are 100 pennies or 100 cents in every dollar. There's 100 years in every century. So cent means 100. So let's say 58% of people for a certain candidate. That's the same as 58 out of 100. If you were to type that in your calculator, 58 divided by 100, that is the same as 0.58. So all of these are different ways of saying the same thing. So 58% is the same as 58 out of 100, which is the same as 0.58. When we are working with explicit equations for exponential growth, have f of n equals f of 0 times r raised to some n power. Our rate here always needs to be in this decimal form. Let's practice finding some decimal versions of other percentages. What if I have 2%? 2% is the same as 2 out of 100. I turn that into a decimal, that is the same as 0.02. What if I have 137%? That is the same as 137 out of 100, which is the same as 1.37. What if I have 49%? That is the same as 49 out of 100, which is the same as 0.49.
Let's look at this scenario we got going on right here. So let's say that you start a new job and they tell you that you're going to start out making $70,000 a year, and every year you will get a 3% increase. Let's just say for cost of living or whatever it is. So you start at $70,000 and then each year your salary will increase by 3%. And we want to figure out how can we represent this in an explicit equation. So let's first think about what is actually happening. So if we think back to the last example in our video, we talked about how we can write 3%. 3% is equal to 3 over 100. If you divide that in your calculator, that's equal to 0.03. Okay? So we're going to take our original $70,000 and we're going to multiply that by this 0.03. And if you type this into your calculator, you're going to get 2,100. This $2,100 obviously isn't how much we're making that next year, because that would be a huge pay cut. And we know that we are making a 3% pay increase. So we know that the amount we make the next year should be more than $70,000. So this $2,100 represents how much we're making on top of that $70,000. So we have that $70,000 plus $2,100, which is going to give me $72,100. So this is saying I'm keeping 100% of the salary I was already making. I'm adding on this 3%, right, that we found by multiplying by 0.03. And that is making a total of 103% of what I was making the previous year. So we can come back up here and we can say 103% is equal to 103 divided by 100. We put that in our calculator. We see that that is 1.03. So we know that our common ratio is going to be 1.03 because I'm keeping 100% of the money I was already making, and then I'm adding on that 3%. So if I want to go write that in an equation, I now have all the pieces that I need. So I can have f of n is going to be equal to f of 0. And we know that f of 0 is the amount of money that we'll be making when we very first start our job. So that will be $70,000 times our multiplier, or our common ratio, which is 1.03 to the power of n. So with this equation, we could figure out how much money we would make in n years, right? If we wanted to figure out how much money we'd make in 10 years, we could plug in 10 for this value of n and figure that out.
All right, let's look at another example, but instead of increasing, like a 3% increase on our salary, let's talk about decreasing percentages. So a real life example are cars. When you buy a brand new car, it's great, but then year after year, it depreciates in value, or it loses its value because obviously new cars are coming to the market and you've been driving it more, so the value of the car is decreasing as time goes on. So let's say you buy a car for $40,000. Ooh, pricey car. Not as expensive as a Tesla, something like that, right? Okay. And on average, we looked it up, cars depreciate about 15% every year. So it depreciates or it decreases by 15% every year. And I want to know how much is my car going to be worth after n years. So let's write our equation to help us out with that. So f of n is how much our car is worth equals f of 0 is how much is my car worth after 0 years. After 0 years, it cost me $40,000. We know our car's initial value starts off at $40,000. All right, and then we got to figure out our ratio now. So Emma was showing us how on the last example we had 100% and then we're gaining 3% every year. We're implementing a similar idea, but instead of increasing, we're now decreasing. So instead of adding, we're actually going to be subtracting because 100% of my car's value now is losing 15%, and that is the same as 85%. So losing 15% each year is the same as only keeping 85% of its original value every year. So to turn this into a multiplier or into the common ratio, 85% is the same as 85 out of 100, and that is the same as 0.85. So notice that there's no 1 in front because I'm not keeping 100% of my car's value and then it's growing. I'm actually losing a little bit. That's why it is less than 1. So we got 100% and we're decreasing 15% every year. So we're losing 15%, aka we're only keeping 85% of our car's value, which is the same as 0.85. So our ratio is 0.85, and every year that is every n. So this would be the equation that would represent our car depreciating 15% every year. All right, in this section of the video, we're just going to talk about how to find the multiplier given a description. And again, multipliers are helpful for finding our common ratio when we are writing the explicit form of some geometric equation or some exponential equation. So this is just to help us find R when we're giving a certain percentage. Now let's look at decrease by 8%. If I'm decreasing by 8% to find my multiplier or to find my common ratio, that is the same as 100% of what I had before. And if I'm decreasing by 8%, I am subtracting 8%. So that means I'm only retaining 92% of what I had. So my R, or my multiplier, would be 0.92.
Whenever we're increasing by a percentage, we have to remember that we are keeping 100% of what we already had and then adding on the other percentage onto that. So we're going to start with 100%, just like we did with our decreasing example, and we are going to add on that 12%, which would be a total of 112. And if we want to write that as our common ratio, we know that that will be 1.12.
For this last example here, we're increasing by 9%, so we keep 100% of what we have, and we're gaining 9% more, which is the same as 109% increase. 109% is the same thing as 109 out of 100, because it's per 100, and that's the same as 1.09. So our multiplier here is 1.09.